Hayalperestlerin, risk alanların, denemekten korkmayanların cesaretinden doğduk. Bizi asla yarı yolda bırakmayan o sesin rehberliğiyle ilerlemeye ve öğrenmeye devam ediyoruz. Bunun için varız. Bu yüzden gece geç saatlere kadar lambalarımız sönmez. Elveda demek hem hüzün hem de gurur verir. Her şeyi sorgulayarak ve merakımızı besleyerek, dayanıklılığımızı test ederek, sınırlarımızı aşarak, ilerleyerek ve yeni ufuklar açarak yeni bir yol buluruz. Yeni icatlar çıkararak, kendi yolumuzu çizerek. Burası fikirlerin doğduğu ve yeni fikirleri doğurduğu, bizim de doğduğumuz, birlikte büyüdüğümüz ve yükseldiğimiz yer. Burası Yakın Doğu Üniversitesi.
Good morning. Hello, everybody. I would like to say welcome you all to our workshop, En route workshop. Today, I am planning to talk about en routes and water, energy, food nexus. En routes developed by Climate Interactive and MIT Management Sustainability Initiatives. This is our contents. I am planning to make a simple introduction about en routes. Later on, our subjects will be climate change, water, energy, food nexus, en routes and water, energy, food nexus, using en routes for water, energy, food nexus research and papers. Finally, conclusion. Let's start with en routes. Simple, together with a simple introduction. En routes is a cutting-edge simulation model used to test climate solutions and generate climate scenarios for the future. En routes is an interactive climate solution simulator developed by Climate Interactive and the MIT Sloan Sustainability Initiative. It helps users explore the potential impact of different climate policies and solutions on global temperature rise, greenhouse gas emissions, and other key climate metrics by 2100. With en routes, users can model the effects of policy changes in areas like energy sources, transportation, industry, land use, and carbon removal, allowing them to see how different strategies could work together to limit global warming. En route is used by policymakers, educators, business leaders, and the public to explore what-if scenarios, promoting a deeper understanding of complex climate systems and the trade-offs associated with different strategies. It's known for being accessible scientifically, rigorous, and designed to foster dialogue about climate action. 5 en routes workshop we organized until now. The first workshop was about how it works. Hybrid workshop on climate change and simulation of its scenarios using en route tools. 22nd November 2022. Second workshop about how to practice en routes from theory to practice. 10th May 2023. The third workshop was about how to practice En-roads on smart cities. Practice on smart cities. 3rd November 2023. Fourth workshop was about how to practice En-roads for energy sector. Transition to sustainable energy. And fifth one was about how to practice En-roads in civil engineering. Application in civil engineering. 6 November 2024. All these presentations, workshop, recorded as YouTube link. You can reach easily to our link to remember what did we do before. Now, let's come to the second topic, climate change. Let's look at the climate change. Climate change refers to long-term shifts and alterations in temperature, precipitation, wind patterns, and other aspects of the Earth's climate over extended periods, typically decades to millions of years. Currently, the term of describe recent and ongoing warming primarily caused by human activities, particularly the burning of fossil fuels, deforestation, and other processes that release greenhouse gases like carbon dioxide, methane, and nitrous oxide into the atmosphere. These greenhouse gases trap heat within Earth's atmosphere, creating a greenhouse effect that leads to global warming. These warming effects, weather patterns causing extreme events like intense storms, droughts, heat waves, sea level rise, and shifts in ecosystems and biodiversity. While natural factors like volcanic eruptions and solar cycles have influenced climate in the past, the rapid changes observed in recent decades are primarily attributed to human action. To make more clear, let's look at closely to the greenhouse gas effect. This figure gives us a perfect explanation. Most radiation is absorbed by the Earth's surface and warms it. Some solar radiation is reflected by the Earth and the atmosphere. Some of the infrared radiation passes through the atmosphere. Some is absorbed and re-emitted in all directions by greenhouse gas molecules. The effect of this is to warm the Earth's surface and the lower atmosphere. Infrared radiation is emitted by the Earth's surface. The effects of climate change can have significant social, economic, and environmental impacts, affecting agriculture, water resources, health, and infrastructure, especially for vulnerable populations and ecosystems. Addressing climate change involves mitigation and adaptation. Now, let's come to the new topic, water, energy, food, nexus. The water, energy, food nexus is an integrated framework that highlights the interdependence of water, energy, and food systems. These three sectors are deeply interconnected. Water is essential for agricultural production and energy generation. Energy is required to pump, treat, and distribute water, as well as for food production and processing and food production consumes both water and energy. Recognizing these linkages is crucial in managing resources sustainably, particularly in the face of global challenges like population growth, urbanization, and climate change. A key feature of the water energy food nexus approach is it emphasizes on cross-sectoral planning and governance. Traditional resource management has often occurred in silo with each sector pursuing its goals independently, which can lead to inefficiencies or unintended negative impacts. For example, expanding biofuel production to meet energy needs can reduce water availability and food security. The Nexus approach encourages policies and strategies that maximize synergies and minimize trade-offs, promoting sustainable development and resource efficiency. In practical terms, the water energy food nexus can guide decision-making in areas such as policy design, infrastructure investment, and environmental conservation. For instance, promoting solar-powered irrigation can simultaneously address water use efficiency, renewable energy adaptation, and food production. It also supports climate resilience by identifying solutions that reduce greenhouse gas emissions while protecting ecosystems and livelihoods. As pressures on natural resources intensify, the water energy food nexus offers a valuable lens for integrated and adaptive resource management. This is another new topic, en-routes and water energy food nexus. While en-routes primarily focuses on climate-related variables such as greenhouse gas emissions, energy sources, and land use, it also provides insights into how these changes intersect with water energy food nexus. Through interactive scenario building, En-ROADS helps visualize the complex feedback loops among sectors, demonstrating how shifts in one area, like energy policy, can influence water availability and food security. In the context of the water energy food nexus, En-ROADS can illustrate, for example, the implications of transitioning from fossil fuels to bioenergy. While this may reduce emissions, it could also increase pressure on water and land resources, potentially threatening food production and freshwater ecosystems. Similarly, policies promoting electrification or renewable energy can reduce the water footprint of energy production, as solar and wind energy typically use less water than thermal power plants. By simulating such scenarios, En-ROADS encourages holistic thinking, allowing users to anticipate trade-offs and co-benefits across sectors. Ultimately, En-ROADS supports informed decision-making that aligns with the integrated principles of the water energy food nexus. It is a powerful educational and policy tool that helps stakeholders, from students to policymakers, understand the interconnected nature of global systems. By using En-routes in conjunction with the water energy food nexus framework, users can explore pathways that not only mitigate climate change, but also promote sustainable water use, energy access, and food security, fostering more resilient and equitable societies. This is another new topic, using En-routes for water energy food nexus research and papers. Using En-routes in water energy food nexus research provides a dynamic way to model and analyze the interconnected impacts of climate policy decisions on resource systems. As an interactive and scientifically grounded climate simulation tool, En-routes allows researchers to visualize the consequences of changes in energy use, land management, and economic development, all of which have direct and indirect effects on water availability and food production. By incorporating En-routes into water energy food related studies, researchers can present data-driven narratives that demonstrate how climate actions influence the balance and sustainability of water, energy, and food system. One of the strengths of using En-route is water energy food nexus research is its ability to simulate trade-offs and co-benefits across sectors in real time. For instance, a study exploring the implication of large-scale bioenergy adaptation can use En-routes to show how such a transition impacts land use and emissions, while also discussing the resulting strain on water resources and agricultural land. Similarly, researchers can evaluate how aggressive carbon pricing or investments in renewable energy can reduce greenhouse gas emissions, while simultaneously reducing water use in power generation, contributing to food security through stabilized environmental conditions. Moreover, integrating En-routes into water energy food nexus research can enhance policy relevance and stakeholder engagement. The model's user-friendly interface make it accessible not only to scientists but also to policymakers, educators, and the public. This democratization of data helps bridge the gap between research and policy by enabling diverse audience to test scenarios and understand the broader impacts of proposed interventions. As a result, academic papers and policy briefs that utilize En-routes can be more impactful, providing evidence-based recommendations that are grounded in system thinking and align with the sustainability goals of the water, energy, food nexus approach. Now, this is my last presentation part is conclusion. As conclusion, I can say that in the phase of accelerating climate change, understanding and addressing interdependencies within the water, energy, food nexus has become more critical than ever. Climate impacts such as altered precipitation patterns, extreme weather events, and rising temperatures pose significant threats to water availability, agricultural productivity, and energy reliability. En-ROADS offers a valuable platform for exploring how different climate mitigation and adaptation strategies influence these sectors collectively. By modeling global system dynamics, En-ROADS enables researchers and decision makers to assess not only emissions reductions, but also the broader resource implications of their policy choices. As a result, integrating En-ROADS is water, energy, food nexus studies strengthen the capacity for evidence-based, system-oriented policy development. It allows for the simulation of climate solutions in a way that highlights trade-offs and synergies across critical sectors, supporting more holistic and sustainable approaches to climate governance. In a world where resources are increasingly interconnected and vulnerable, tools like En-ROADS are essential for fostering resilient strategies that align climate action with the sustainable management of water, energy, and food systems. Thank you very much for your attention and participation. Now, Mr. Farhad Bolouri will present En-ROADS simulations.
Hello, everyone. Welcome to our workshop, and thank you so much, Professor Dr. Hüseyin Gökçekuş, for their introduction. Now, excuse me. Now we are going to practical part of this workshop to see how we apply what we saw in Professor presentation. Now I'm sharing my screen, and after that, this we will go to sharing my screen and seeing that, because everything is online and on the En-ROADS website. When you can see my screen, I can start. Just seeing if my screen is shared. Yes, please share my screen. Now I can show everything in there. Yes, it is enough to come to the Google and just write En-ROADS and search, and after that you can open the En-ROADS website. You can see here so many things, so many tools, but what we want is just here in the first page, in the first part. You can click here and come to this part, because we need the simulation. If you need any more information, as I said, you can use the other parts of the En-ROADS website, Climate Interactive website. But when you come to En-ROADS part and simulation part, you can see this page. Here you have more than 20 languages, even Turkish, Persian, Arabic, Japanese, Italian, French, and Germany, and the other language we have. But for today workshop, we prefer to present in English. After that, you can come to simulation part. Here you can reset policies, reset assumptions. Policies is this ones. Here we have the options to change. This one's named policies in this simulation. When you click on the reset, all of them resetting for you. Also, we have assumptions. I will show you. Here you have so many assumptions, and you can change which one you want based on the studies you have, based on the references that you have. You can change these ones because behind this modeling, we have more than 14,000 formulas. If you see our first workshop that Professor introduced to you, in there we introduced this. Also, you can use En-ROAD's website. Because of these 14,000 formulas, you have so many assumptions. But as I said, from here you can change the assumptions. We will come to here again. Now I am just want to show what you can see in the first, you come to the website. Also from here you can reset all this policies and assumptions. Also here we have the graphs. These two graphs are our, how can I say, our default graphs, but we have more than 100 graphs. So I will show from so many places you can change the graphs you want to see, but one of them is here. From here you can see and choose them and see them, and also, as I said, from here you can change too. I will show you again from where you can do this. From here you can choose. Also, you can come to the view. From the view, what you can do is to seeing main graphs. The main graphs means these graphs. Also, you can see Kaya graphs. Kaya graphs means global population, GDP, energy, also sea industry and CO2 emission. These are our Kaya graphs. Also, nature graphs you have. These are so important. You will see in the next ones. I will show you. You can choose from here any graph that you want from these mini graphs, and you can see that graph in here as your default graph, and you can do your simulation here. We will come again to here, and you will see, for example, this one is very important, sea level rise and flood risk. We will come to here and I will show you again. Also, you can see from here the actions and outcomes, because I didn't do any action. If we do some actions like this, we do some policies, and after that we click here, the action and outcomes, you can see here what I changed about the oil, renewable, and the other things, and what is the outcomes, for example, for temperature increase, for CO2, sea level rise, and the others. From here, you can choose US units or metric units. We are working with metric units. From here, you can see the show graph template, and also you can say play a sound when you choose something and change. You have something to hear it. We don't need this one now. Also from the help, you can click in the En-ROAD's user guideline and the support, their supporting team. Also, we have En-ROAD's training, users for En-ROAD's, and the other things you can see here. Also, if you do something that like that we are doing now, you have a En-ROAD's event, you can register your event, and the other ones from all over the world can use your event. With this one, all the policies coming to the first place, or reset all. This one take the graphs to the two default graphs that we had. This one's about the policies that we did and to seeing how it's changed. If you do more than one policies, always we are doing like that, and we change so many things. This one is for the last change, just last change. Maybe you changed more than 10 things, but only the last one with this one can change. This one make you the full screen of the simulation. Also this one showing mini graphs for you. We have from here or you can choose from here. Okay, now I want to reset everything and start from the beginning. Now we know what we have in here in the toolbox. So we can come to do the other things with these policies. About the policies, we have these options. The energy sector or energy supply part is very powerful. The En-ROADS actually based on, how can I say, on the energy modeling. We have more than 14,000 formulas. We have so many information, but the base is on the energy. So the energy part is very important and very powerful in this modeling. And also because climate change, as you saw in the slides of the professor, is directly related to the CO2 emission and the other thing. Because of that, energy is very important. Also in the transportation or building and industry, you have energy again. But in the growth part, you have just economy and population. And the other things like the food, because today's workshop is about the water, energy, food nexus. For example, from in the agriculture emissions, you have about the cows, about the food, and the other things that most populated part and the most important part is the methane emission from our food sector. Okay, now if we come to here, we have these options for applying our policies, but what we have here, for example, coal. If you click in this double dot, you can see here more options for changing. This one can change from here, but you don't have any number, okay? Here you can just apply what you think, or just to see when you apply some change, how it affects. But from these three dots, you can change it so exactly. For example, I write 74, you see? Or if you say start here is not 2025, I want to do this, but it will be start from 2030, for example. Or you can say this one not start with 2100 or 21 century. It will be stopped with 2080. Or reducing new coal infrastructure is not 0%, it is 45%. Or anything else. You can see, you can change so many things from here. Also here, you have graphs. Here you have some introduction for this part. Here you have options to change this graph. For example, we say this one or this one. This one is this. Also, from here, if you click in the eye, you see some information. For example, what is the examples about the coal? What is the big message about it? What are the key dynamics? Because this model is a system dynamics model, you know it, modeled on Vensim, and it is a system dynamics modeling as a tool for system thinking. So here you have the key dynamics. Also, you have potential co-benefits of this one, or equality concentration. Some videos you have, you can click and see on the YouTube. Slider settings you have. Also, you have a model structure for this one. You have some case studies, frequency questions, and also some citations you have here. You can read. And you have these ones for all of them. If you do something like this, just changing this number, for example, I make it 50. As you see, the double, the triple dots will not coming highlighted with blue because you changed just this one, this dimension. But if you change something in this assumptions, for example, I make this 2040 or this one 2080, something like this. As you see, the triple dots will come highlighted in blue. Why? Because you change something in assumptions. Even here, if you come and change something in the total assumptions, for example, this one and this one, and you come here, you can see here comes highlighted in blue because you change something assumptions. These are what you can do with all of this one. Now we come to do something and we see how is it going. Here we can use, for example, this one. I want to show this one in the first place. You know about the temperature change. United Nations, IPCC, and the other ones suggest between 1.5 and 2 degrees Celsius, because between this one we can say that we are not in danger. But more than this, with 2100 is so dangerous. So we come here and we say, I'm just changing this one manually, not typing with exact numbers, just seeing how can they impact. For example, in the temperature change, and also here you can see the primary energy. I reduce coal, I reduce oil, I reduce natural gas. Also, very important thing is carbon price. For example, we increase this one, net zero carbon. We use some nuclear, also renewable energy we increase, bioenergy. Also, about the energy efficiency, we increase it in transportation. Also, we use electrification in transportation. About the building in the industry, we use energy efficiency. Also, we increase energy efficiency. Also, electrification we increase. About the population, we are not sure. Maybe some increase in population and some decrease in energy growth. Natural based about the carbon dioxide removal. We increase technical part. We increase. About the agriculture and emissions, as I said, it is about the food and the other things. We say, okay, we decrease this one. About the waste, we decrease this. And deforestation, we decrease. If we do something like this, for example, in the world, globally, you can see that we succeed to come to 1.6 degrees Celsius increase in the temperature, and it is good. Not the best. The best is doing something that we don't have any increase, but we can not do the best. So we are doing our best in our way. So this one is good because it is between 1.5 and 2 degrees Celsius that I said suggested by IPCC, United Nations, and the other organizations that are focusing on climate change. So we have these ones. Also, sometimes we need the data. For example, we say about the, for example, impacts sea level rise, or the other things. So we have this one, this graph. We can copy this graph or we can view it in this situation but for use in your papers, reports, and the other things. Maybe you want to have it, the data in the Excel file. So it is enough to copy the data to clipboard from here, and you can come and open Excel file and just paste the data here. As you see, year by year, annually, for 100 years, you have the data, for example, baseline and current scenario. And from here, you can have your own graph. You can have own graph to see what happened, and even you want to show how in your report and to do anything you want. Just I want to show that you have the same data and you can have your own graph from just copying your data from here. So this is one way, and as I said, for example, you can do something like this, make screenshots, and also you can see we did so many policies and they start from today. But for sea level rise, it takes so time to come and affect on the sea level rise. You can see we do the policies from today, but they come to do something for us at least from 2050 because it takes it has a delay in system dynamics. One of the most important things are the delays. You do something, you have some policies, you apply from today, but their effects comes feasible or effective more than sometimes, as you see, after 25 years, because it takes time to affect. Sea level rise is one of these. So, for example, here in the impact part, I want to show you, for example, this one. Sea level rise flood risk map. Because as I said, this one, the sea level rise, takes time to see the impact. I write here Cyprus. So we focus on Cyprus, but I will show you, for example, from Turkey and the other parts too. Here, I make this one bigger to show you. As you see, for example, in the Cyprus, in this part, Limassol Salt Lake, we have the danger, land at risk, and the lands that saved by our these so many actions, just these little parts, you see. The most of the part are in most dangerous parts. Also, we can change this one with the long term, for example, equilibrium. Also, you can see in a long term, also we have the dangerous parts, and the most of the land around the Limassol Salt Lake are in danger, but we saved some parts here. But this is not limited just for the Cyprus and some parts. For example, the northern part has the dangerous parts, but we can save more parts with our actions. Also, if you come, for example, Turkey, here is the Turkey, and also, for example, this part is Antalya. You see, in Antalya, you have so many parts in danger, and just with these actions, we can save half of them. Or this part of Antalya, you see, these are the coastal parts. This is a very big city. And here is the university and the other parts, and all of these are one of the most crowded parts of Antalya. But you see, all are in danger of this land, but with these policies we can save these parts at least. So we can say we did something. And this model is global modeling, but as always, just think globally but act locally. When you do these things, you can see how is the effects locally and how can it save for you. Our workshop today is about water energy nexus, so it is better to focus on the other parts too. Until now we focused so much on water part, but we can show you, for example, the air pollution from energy. You see, in energy sector, you have so many graphs. For example, with energy, I will show you. But this one is the environmental part of this. For example, for air pollution from energy, you see, this is PM 2.5 emissions. You see, if we don't do anything, it is our baseline that goes with this. And you see how much megatons you have PM 2.5 per year. But with these actions, you can see we decrease it from around 26 megatons to, as you see, 2 megatons. We decrease at least 24 megatons air pollution, PM 2.5, with these actions. But these are so many actions, as you saw. It is one of the best scenarios that we did. Also, you can share your scenarios. Before I forgot, I can say this one. From here, you can share your scenario. When you do something like this, here in the En-ROADS, you can share it in your X or Twitter, Facebook, LinkedIn, email, or copy scenario link. When you copied it, just like what we have here for the data in the Excel file, you can copy and paste it in the Word file. When you writing your paper, presentation, report, you can put this link, and anybody with clicking there, they come directly to your this model. And anybody wants, they can change, they can see, but this one will not change for you until you want to change. So these are what you can do from here. Also, in this photo I want to change. We have so many things here. We have, for example, greenhouse gas emissions here. Different greenhouse gases that introduced with Professor to you. For example, methane, N2, N2O, and the other ones. You can see here, and you can see what happens. CO2 emission is different. They didn't include CO2 in the greenhouse gases, and they separated because, as you saw, in the climate change, the temperature increase in the world, global warming, we say, it directly depends on CO2. So CO2 is so important, and they separated. And here you can see around 20 figures, around 15 figures you have just for CO2 from energy and industry, from the oil area. And you see here, because we changed in the oil, you can see how is it changed. If I can do like this, you can see how is it changed with just oil. But just not oil, we do it so many policies, so you can see how is it going to change. Also, if you want, from here you can read, and with clicking you can go to the citations. That's what means this figure for you. Also, here we have Primary energy demand, you see here we have, for example, these ones and the other things. I want to show you the important things. Primary energy demand types we have, for example, with coal, oil, and the other things. For example, this one is the coal primary energy demand. If we change this one, how does it change? Anything. Not anything, but just little, because we have so many other alternatives, and also these ones, the energy efficiency or carbon price, net zero, and the other things that we changed. So just the coal is not so affect this one, but for example, carbon price has more thing in this policy. Also, the final energy consumption totals, for example, you have, or final energy consumption by the type you have. Here you can see how's it, or with economic growth. You see, economic growth is not good always. It is good, but not always. For example, here, when you have economic growth, total final consumption of energy sources for you increases because you have money, enough money, so your consumption of the energy is going higher and increase because you have the money, you pay, and you use more energy. This is what we have. But for example, here we have the consumption of the different energy sectors. For example, oil. If you see here, you can see the oil final consumption. How does it change with our policies? For example, if we use more nuclear and more renewable energy and we increase our energy efficiency, how does it change? Or we decrease our oil and we increase our carbon price. Carbon price is one of the most important policies between these policies about the energy sector, because with energy price increasing, you affect all of them. Because with the carbon price, you force all factories and big factories to decrease their carbon emission, carbon dioxide emission, because they have to pay how much they introduce and they emission CO2 to the environment. They must pay to the government, so they have a limit here. Also, land, forestry, and food. You can see here deforestation. You have forest area. You have about the agriculture. You have farmlands and the other things. Also, you have about the land use, farming, and the other things. For example, here we can come to crop yield. Yes, you can see here. These are most affected with these policies, but not so much. Also, we have deforestations, agriculture production. Yes, you can see total agriculture production. With these policies, it comes like this. But I think with population, yes, as you see, this one is so affected by population, because when you have more population, you need more agriculture production. When you have less population, you need less agriculture productions. Here is good to see some mini graphs too. You see, without these policies, we have so many effects. For example, on CO2 removal. You see, this is what we did with this our policies. This is about the removal. This increase are good, because these increases are showing us increases in our removal, not increases in some parts. Increases are not good, because that was, for example, meaning increasing in CO2 emission and something like this. But this increase is better because we remove all carbon dioxide. I can show you here. Yes, we have so many actions, as you see. From here until here are our actions, and just here our outcomes. And also in the mini graphs, yes, as you see, we have so many things. Also, if we come to here, but we have another graphs to show you about the energy, water, and food. Yes, CO2 removal. Yes, here we saw one example from here. Also, population and GDP we have that we did, for example, here about the decreases in population. Financial part we have. Financial part, you have so many things. For example, market price of coal. You see, with taxes, the price increases because we said carbon price, for example, increases. You see, we decrease coal, but as I said, carbon price increases. You see, effects are so bigger. It is so great policy. Also here you have some model historical data and the other things. You can see from here from 1990 until 2023 for 33 years. You can see the historical and En-ROADS, how it can push it, how it can cover it, so you can trust an En-ROADS model. This is for this, but for the last ones, I come again for the impacts. Most of these impacts are recently added, so please come to the website and see all of them because they are so important. So better we discuss some of them, for example, air pollution and the other sea level rise, but you have so many, for example, wildlife in danger or wildfire danger days from warming map. For example, for Cyprus, you can see again how is it going. Yes, you see as you see, Cyprus will be in danger, the central part. But for example, as I said, we are not focusing on just Cyprus. For example, in Turkey, you see some of the parts, northern part, are very in danger about the wildfire danger. Or in Greece, you have the same. In Russia, the other parts. So these are important to see what you can do and how is our world going toward. Or other ones from here, temperature change we saw, methane we have, pollution we discussed, deaths. For example, deaths from extreme heat, you can see here. And you see, if we don't do anything and it goes like this, our world, this is the baseline, and with 2100 we have 26 deaths per 100,000 people per year. But if we do these policies, for example, you see we have about 10, around 10. From 26 we come to 10. 15 deaths less we have, and this is very good for us. Also from here you can see the other ones. Ocean acidification we have, for example, arid land, we have ecosystem shift from this one, and also species losing, you can see here. So you see from our actions how it comes from, for example, 50% to 10%. Or in insects we have the same, or for planets we have from 45% to 11%, or for mammals we have from 24% to 5%. So you can see how affect our these actions, for example, for species. So this lesson and this part of the workshop was just to introduce this environment, how to work with En-ROADS, how you can do anything, and you can choose your language. You can did something with the simulation parts. We have which graphs. We change the graphs from here, but also you can change from here. We have about the views, Kaya graphs, and the other graphs, also the other things. So for today, we stop here. But if you need anything, you can use my email and talk with us, contact with us. I'm ambassador of this platform in Cyprus. You can reach to us and we can help you in your research or the other things. But for change these things, for the last thing I want to say, for changing these ones or changing from these assumptions, you can read some papers, some books, and you can change these assumptions with this information that you get from the books, the papers, and the other things. And after that, you can change some assumptions, or you can change these ones exactly. And in this one, your report can be came as a paper, as a valuable report, and anybody can change. But with your mind, you can do some policies today, but we did now here, and just see how your change affect on the environment and globally. Okay, thank you so much for your attention, and hope to see you our next workshops. Thank you so much.
Hayat hızla akıyor ve biz bu hızı seviyoruz. Her güne heyecanla başlıyor, her anı doya doya yaşıyoruz. İlk günkü heyecanımızla yılları aşıyoruz. Zaman akarken biz de kendimizi arıyoruz. Heyecanla, merakla. Sen de kendini mi arıyorsun? O zaman zamana yetiş. Bu sadece kendini bulmakla ilgili değil. Asıl heyecan kendini yaratmakta. Bir şeyler mi yaratmak istiyorsun? Mükemmel. Metali işlemeyi, bir bina yapmayı, bir iş kurmayı, hatta bir şehir kurmayı öğren. Hayat kurtarmak, teknoloji geliştirmek, üretmek. Hepsi burada. Ve burada tüm deneyimler profesyonellerle yan yana. Ancak hızlı ilerlemeliyiz. Çünkü bugün şimdi gerçekleşiyor ve yarın çok yakın. Hayatta öne geçmek istiyorsan önce zamanın önüne geçeceksin. Hep ileri gideceksin. Bu Doktor Suat İrfan Günsel. Tanıyor musun? Onun da söylediği gibi. Üniversiteler toplumların dokuma tezgahıdır. Toplumları geliştirir, dönüştürür ve gelişmesini sağlar. O burayı bugünden yarına hazırlamak için kurdu. Senin için, ileriye gitmek için. Yana ya da geriye değil. Sadece ileri. Çünkü gelecek çok yakın. Hadi harekete geç. Fikirlerin ne kadar ileride olursa yarına o kadar yaklaşırsın. Yanındakileri de geleceğe taşırsın. Bu senin geleceğin, senin fırsatın şimdi. Hadi yarın yakın. Hepimizi ileriye götür.